We do not do wastewater treatment. We don't do the biology. Cuba is a German company based in Bavaria, just north of Munich. We're a global company producing wastewater solutions. So that is solutions for wastewater, for clean water, and industrial wastewater projects. Yeah, well, as you'll be aware, the world has not been a predictable place with COVID and wars, and so in this industry, we have to live with penalties so that we can manufacture everything for the US and Canadian market here in the United States. Chamber, which is a concrete chamber. We have various sizes, but this might be 30 to 40 feet long typically, and perhaps 15 to 20 feet deep. Or do we want to dry to, let's say, 90% dry solids? So that will reduce it down almost to a powder. Like what will landfill accept? Every state's different. How far do we need to transport it?
Here at WEFTech with Simon here at Huber Technologies. Thanks for meeting with me today. Kind of give me an overall high-level view of what you guys do.
Okay, so Huber is a German company based in Bavaria, just north of Munich. We're a global company producing wastewater solutions. So that is solutions for wastewater, for clean water, and industrial wastewater projects. Our main customers would be the municipalities.
Do you guys got any current plans, anything kind of forward thinking that you guys are working on?
Yeah, well, as you'll be aware, the world has not been a predictable place with COVID and wars and climate issues. And so we have decided to fast track and increase the manufacturing capacity in Denver, in North Carolina. That's Denver, North Carolina, not Colorado. And we have a small factory there of 66,000 square feet. And we're expanding it to 205,000 square feet so that we can manufacture everything for the US and Canadian market here in the United States. So whereas before we've been importing it from Germany, so now we want to be under our own steam.
Yep.
And also that means that we can comply with this Build Back America Act that you might have heard of.
Yes.
And the Inflation Reduction Act, so that we will be able to comply with those policies so we can accept the funding.
That makes sense. So what are we looking at here?
You're looking at what we call in the industry a screen.
Okay.
So this is normally found at what's called the headworks, which is the first thing that you find at a wastewater treatment plant, or it sits in front of a pumping station to protect pumps. And the quickest way to describe it is all the wastewater with all the solids is flowing into the center of that drum. The solids collect on the face of that drum, allowing the water to go through. And then periodically, there's rakes in there that sweep around the bottom, lifting the solids to the top, and then it's swept off the top into what's called a washing compactor. This machine here washes the screenings to get rid of all the organic material, and then puts a dry, clean product in a dumpster so it's ready to go to landfill.
Nice. What are the kind of rake that separates it from others?
Well, definitely it can handle massive flows in a relatively small footprint. This is a small one, but this screen can be over 70 feet tall. So you can lift stuff up from a sewer that's way down the bottom and take everything up to the ground level. And from a maintenance standpoint, there are very few moving parts. So this screen, even though parts move, you haven't got bearings. You've just got a simple scraping device on top, so you don't need any wash water. So I would say that the simplicity and the robustness are what people like.
Okay. Neat. So you said it could lift at 70 feet. So does this essentially, if it went in a vault, or they go in vaults or manholes or?
Channels or chambers. This plastic bit at the side here, this is trying to show you what a concrete channel would look like. So that's what this is. And so the water level will be down here. But this part here that you see here, that's just basically an elevator. So that can just be another 50 or 60 feet.
Yeah.
And then these rakes just drag the stuff as high as you need it and that's the head at the top, the headspace, and the material is pushed off the headspace.
All right, what is the grit rule?
Well, the grit rule removes grit. So people who don't understand wastewater probably don't understand that a lot of the grit, the small stones, etc., get washed down from the roads and find their way into the sewer system. And that can cause havoc on the treatment process. Grit is like sandpaper. It wears pumps and valves, and also it settles in chambers, so it changes how the chambers work because they're filled with grit. So they're reducing the volume. So once you go through the first thing, which is a screen that takes out the plastics and the paper,
So it's bigger,
the big stuff, then this is a grit trap, which is, as its name suggests, it is removing the grit, like fine sand. And
so yeah, like you said, works like sandpaper.
Yep.
Wears out the valves.
Yep.
Okay, this one, at least to me, this looks like this is a pretty big area. Is this?
Yes.
What? So where does the kind of walk me through? Where does the water go in?
Okay.
Where does it?
So the flow is coming from this side and exiting out this side, and this
same channel.
Yes. So that will come directly from that previous bit of equipment, the screen. It'll enter into this chamber, which is a concrete chamber. We have various sizes, but this might be 30 to 40 feet long typically, and perhaps 15 to 20 feet deep. So all the flow is flowing across this chamber. Initially, we inject air into it. Air circulates and washes the grit. Why do we wash the grit? Because grease and fats will be on the grit. And to make it easier to sink and to settle, we like to wash off the grease and fats. Then what these are showing here are what we call lamella packages. Now, again, I won't go too much into the science, but when you have a greater surface area, it's easier for the grit to adhere to the surface area and sink. Okay, so they're called lamella plates or lamella packages. So they enhance the grit settlement. Grit sinks to the bottom. And then if you look in the bottom, we're showing a shafted stainless steel screw. And that screw moves all that grit to the end. It drops into what we call a sump. And then a pump will pump that grit to a dewatering device, which is not shown here. But then you need to get rid of the water and put it into a dumpster. So this grit wolf is what is called a high technology grit removal system, because it is settling out much, much finer grit than traditional grit systems.
What do traditional grit systems aim for?
About 300 microns. Okay. And this is aimed at 75 microns.
Kind of what's the kind of maintenance on one of these? Does it have a backwashing cycle, or does it pretty self-maintaining?
Well, maintenance is always needed, but so a clever design is to maintain those lamella packages. They just need to be periodically washed. We're designed so each one of them can be lifted up with a crane individually and washed with a pressure washer without turning the machine off. That's the important part of it.
You don't need a second train of these. You can just pull out, rinse, it's still going.
Yeah, you pull them up, pressure wash them, lower them back in place, and you haven't stopped the stream of water going through it.
Do a lot of these grit traps, do a lot of other manufacturers, do they need to have a second train because they have to take the whole thing down to work on it? And that's a huge deal.
That is a huge benefit of this system. Our main competitors, to maintain what they call the stack trays, the system has to be isolated and the whole thing needs to be taken apart. So Huber's business is basically separation of solids from water. You saw what's called the headworks with screens and grit. We do not do wastewater treatment. We don't do the biology. This next section here is handling sludge. So the biology collects the sludge, and pumps the sludge away. That is a waste product. That is generally of no use. So what the wastewater plants need to do is they need to reduce the volume of that sludge so they're not paying to transport water off the sites. That's very expensive.
It's heavy too.
Yeah, it is heavy, and they want to get rid of the water, make it as small as possible so that they reduce transport costs, and they provide it in a format that's acceptable for the landfill sites to take. So this piece of equipment here on my left is called a strain press. So when the sludge is pumped from the clarifier, it can still have rags and plastic in it. So those need to be removed. And so this is what's called a strain press, because as its name suggests, it is straining the sludge, allowing the clean sludge to go to the next phase. And whatever residue, paper and plastics, which was left from the screening side of things, drops out here into a dumpster. If you look here, you'll see what the screen looks like. It's a very fine perforation to get out the hairs and the fibers and the non-biodegradable material which is left in the sludge.
All right, so this is after the clarifier, it's settled out, and it's getting essentially pumped into this strainer.
Yeah, strain press.
It's getting essentially squeezed down the line.
Yep.
Does it dry it out too? So it does dry it out. So this comes out like just sludge cakes?
No. This is where the fibers and plastics drop out into a dumpster.
Okay.
This is not dewatering the sludge. This is purely straining the sludge to get out the fibers and the small plastic elements that have escaped the initial screen at the headworks.
Okay, so it's another form of screening. Okay.
The main difference between the screen I showed you at the start and this screen is, number one, it's finer, but this is designed to take a pumped flow. So the flow is under pressure. The screen I showed you at the start is in an open channel. So it's taking water flowing at perhaps 3, 4, 5 feet per second down an open channel. This is taking a pumped flow, which is under pressure, and this needs the pressure to work. So it enters from underneath through a pipe rather than a channel.
Right.
So this does not sit in a channel or a chamber. It sits on a floor, and you connect it up with probably a 4 or a 6-inch pipe.
When you're speccing out and your plant's going to have a strain press in it, what are some of the key points to consider?
Well, we need to know the pumping rate because we have different sizes. So we need to know what it's being pumped at and what the density of that sludge is in terms of, is it 1%, 2%, 5% sludge? So we need to size the thing properly. That's the most important thing. And then we often offer pilots for all of our equipment. We have to offer what we call pilots, free pilots that we allow the site to work it for a week or so. Because the other thing we need to work out is what size of openings do we need to have on the basket? A 5mm opening is standard, but sometimes if, for example, the sludge has all gone through a grinder, the particles could be smaller, so we need to go down to perhaps a 2mm or a 3mm basket.
It would be like if your system had a bunch of E1 systems in there, just grind. If you lived in just where the individual homeowners just ground it up and sent it in here, you're going to be looking at a different screen than a flat place that has no lift stations in it at all going to your plant.
That's exactly right. That's the main determining factor, is how small the particles are that we need to remove. So really, because there's no chemical addition with this is purely a screen. So just to reiterate, the sludge comes in and the sludge comes out in exactly the same format as it went in, apart from the fact that we've taken out hairs, fibers, and small bits of plastic and paper which have escaped the headworks.
Which can just go in the trash can.
And they can just go in a trash can and go to the landfill site.
All right.
So that's the strain press for screening sludge. And then on the other side here, this is a more sophisticated piece of equipment. This is a screw press. Now, this is the machine that would take the sludge that will be very, very liquid, maybe 1, 2, probably no more than 4 or 5%. And it will go into this machine. And this job is to dewater the sludge to a point that this is what drops out the cake of sludge.
So this whole thing gets filled.
Yep.
And it ends up being this small when it comes out.
Something like that, yes, pretty much. So there's the inlet. Now, what will happen before that is, and again, please, I'm no expert in this area, but we will add a polymer. A polymer creates flocculation, and that makes the sludge easier to dewater. So virtually every time we sell this machine, either us or a separate vendor is supplying a polymer pump to inject the polymer into the sludge.
Before it, like as it's coming in?
Yeah, just somewhere here,
right, okay.
You know, and then give it time to work. And then it goes into the Q press, as we call it, which is a screw press. And then the sludge flocculates, and that makes it easier to remove the water, and you get better performance of your sludge coming out the end.
So when an engineer or a municipality is looking at speccing one of these screw presses out, what are some of the key points that they should be looking at and selecting it?
Right. Well, that is a bit more complicated because nearly every time we sell one of these, we have to do a site pilot.
So it's very specific.
Yeah. And we do what's called a bench test. So we have a lab technician, and she has all the polymers, and she works her magic that I said I know very little about, like a sort of a science experiment. And then we will send back the customer a report telling them what we think we can do for them in terms of dewaterability and how much polymer we would need to do to achieve that. Now, they might come back to us and say, well, that's not acceptable. And we say, well, thank you very much. But if they say, yep, you're in the ballpark of what we want to achieve, then we'll offer to send a slightly smaller one than this to site in a container. And we send a technician, and he will run it for them for a week. And we try different polymers, and we measure what comes out the end. And then we produce a final report for them, which then will develop the specification and the performance guarantees. So in this industry, we have to live with penalties. Right. So we don't want to tell anyone that we can do something unless we're pretty darn sure we can do it. Yep. So we might come to them and say, based on your flow, we can produce 20% dry solids using this much polymer in a year. And then they will make the decision if that's acceptable. And if it is, we will then bid the job and hopefully win it. So we need to know throughput, and we need to know what they're looking to produce coming out of the end. That's the bottom line. Often that is acceptable to take to landfill. Okay, it's pretty dry. I mean, you can squeeze water out of it. So often that's enough. But then what a lot of sites are now doing are weighing up the cost of, do we want to dry to, let's say, 90% dry solids? So that will reduce it down almost to a powder. And I can show you some examples when we move over there. And is it worth us doing that? Because you're now looking at pieces of equipment that can be $4, $5, $6, $7, $8 million. You're looking, I mean, I give you that range because it depends on the size of plant, but you're not looking at a small change here. You're looking at big investments.
So is this targeting like a pretty, I mean, you have to have pretty high amount of waste in your system?
It's not necessarily that, because some of them are doing regional plants where 4 or 5 small plants get together and do it in one space.
Oh, okay.
But it's more about what is the landfill rules? Okay. What will landfill accept? Every state's different. How far do we need to transport it? If a wastewater plant can go to a landfill in 3 miles, then you might as well just keep dewatering it. But if the landfill site is 100 miles away, then they might want to save more money on transport costs.
That makes sense.
And some states won't accept it, so they have to transport this to another state.
Is it because it's industrial waste?
No, just whatever the landfill regulations are and the permits.
Like if it's in California, you might have to ship it to Nevada.
Something like that, yes. So somebody, their consulting engineer and the plant are making a decision whether this is a viable thing to do. So if they decide it is, we could then talk about 2 options. This is my personal favorite. This is a solar dryer. So obviously in this world, we're trying to reduce our fossil fuel usage. And this is the way that sunny climates can do it. Arizona, California, Florida, mainly the Carolinas, Georgia. We're just installing one in.
Without rain?
It's the solar energy. Okay. And so what you've got here is a 400-foot long greenhouse by about 40 feet wide. And the sludge from this dewatering device will be conveyed into here. And what we've got in the middle here, this is a conveyor, number one. It drops it down there. And then this plow is called a turning device. And it goes up and down on rails. And it is churning that sludge. It's turning it like a plow, going through it, turning it and flipping it over so that you get unified drying. Then after a period of time, that plow picks it up, takes it back to one of either end, drops it into another conveyor, and that conveyor drops it into a dumpster. So it really is that simple. And
you said it can get rid of 90% of the water that was left in it?
It can do that, yes. And
what is that in like terms of weight?
I don't know about weight, but if you've got your camera here, that's it. Yeah. That is from one of our dryers in Arizona. Sometimes they pelletize it.
Oh, wow. It uses fertilizer at all?
Well, that's...
Is there a next step in it?
That is a really, really, really good question. So that's solar drying. This is the one that really dries it. And I'll get to that question about fertilizer. This is a belt thermal dryer. So you're looking at a really complicated piece of equipment here, but you're looking at a massive hairdryer. So within that box there, you have got a conveyor belt, which moves to the end, drops it down onto another conveyor belt, and moves it back again when it drops into a conveyor and can be removed. What you're seeing on top is hot air supplies. We are rotating air through a set of heat exchangers, makes it very hot. It's passing through the belt, and as the belt is trundling along very slowly, at each of those sections, it's being hit by hot air.
Yeah, just drying it out.
Just drying it, and this will guarantee 90% dry solids. We can provide a guarantee on that, and that's what really produces the very driest sludge.
It's pretty, doesn't feel, it's not that heavy.
No. And there's a lot going around there in terms of pumps and storage hoppers and condensers. But the core thing that we manufacture is that belt thermal dryer, which is the belt and the hot circulating air. Now, this is the product where we can guarantee producing a product that the municipalities can either sell or give away as a fertilizer to farmers, sod growers, and the general public.
So it's kind of a two cost, and you switched it from being an ongoing cost that they have to pay to have it hauled, and you've now flipped it around, and now they're essentially selling the stuff that comes into their system.
More often than that, they give it away because they have zero transport costs. So we have a large installation close to us, near to our factory, a place called Mooresville in North Carolina. I think we installed it in 2013. They've got to the point now where they do not have any freight costs. They give away every single ounce of dried sludge.
People are begging them for it.
People turn up with their pickup trucks, and they have contracts with farmers that come with big trucks and take it away by the truckload. But they have zero freight costs. That's probably saving them maybe $300,000 a year.
A year. And that's why you were talking about the multi-million-dollar project, because they're going to save it in 10 years.
Yes. What is the return on investment? Right. And so that's, let's say for argument's sake, one of these is $6 or $7 million. Someone smarter than me is working out, what is the return in investment.
I think a big thing when you talked about shipping costs is there's been a lot of inflation lately.
Yeah.
Shipping costs have gone through the roof. If you had one of these installed, you're not going to be subjected to that. You've already essentially paid for this, and you're not going to see that huge increase. Wow. Yeah, thank you very much. That was super insightful. That's all I've got for today. That was amazing. Simon, thank you so much.